Mark Griffith here and welcome to RCHacker. Now I've got two Naze32 boards here. On my left I've got a Naze32 Acro and this is a Chinese copy. I won't say where this one came from. And on my right I have another Naze32. It is an original one from Timecop and this one was, I bought this one from Next FPV. I bought this one myself. And I thought before I put these into back into their airframes again, we'll have a closer look and just have a look exactly what the differences are with these. So I've got a macro set up here. They're pretty small. We'll have a look at under these. And I've also got as well a Afro Mini that I got as well. You can see the size difference there. It's got all the same features. Well, not quite. It's got more features than the normal Naze32 Acro. It's got a barometer and a compass on board, I think. No, just a barometer extra and the accelerometer. But it doesn't have a USB port. You've got to connect to an FTDI. So we'll have a look at that as well while we're at it. All right, let's go. Okay, hopefully we can see these clearly now. And I've got them side by side on the left here. This is the copy, and on the right, this is brand new, straight out of the packaging. And I've been using this one here on the left here. And you can have a look at the soldering here. There's a lot of gunk still left on the board, and I'm going to have to zoom in so you can get a closer look at it. But if we look underneath, you might be able to see that there near those numbers. All that residue was still left on there when I got this thing, this white powdery residue sort of thing. So this one, when I got it, it wasn't clean at all. That's like just a bit of flux compound left over. It's not necessarily going to affect anything, although I have had issues with leaving flux on boards before, and it's caused problems when I was building my own little gimbal boards just with the pins around the microcontroller. But it's not necessarily going to cause a problem with these ones. Although with this, I did have a problem with the FrSky output. I've got to investigate it further, but I'm not sure if this board here is quite handling the inverted output for the FrSky telemetry as it should, as this other one should. You know, we'll look at the looking at the new one. It's very clean. There's no residue left on there, solder wires and all that sort of thing. First thing to do, one way to tell the difference is over here. These ones, they've got a silver. This is a silver crystal. Now this is where the main CPU or MCU here gets all its timing information. That's a 12 megahertz crystal there. And on this one, it's got a silver can, and on the other one here, it's got it's a solid black looking thing. So that's an easy way to tell the difference between the two boards and where they came from. Right, we'll have a quick walk around and I'll show you all the parts on here. This is the main MCU. It's an STM-F103, the main processor on here. They run at 72 megahertz and it's pretty cool. They're the bee's knees for flight controllers at the moment. Kind of taken over from the old 8-bit AT Mega hardware in a lot of other flight controllers, which are basically Arduino, like old school Arduino based. Moving around, the main difference between these two boards, this one is a Acro version and this is a full version, so it's going to have a few parts missing. One part that's missing is this one under the mounting direction arrow, and this is a bit of a data flash. It's a data flash chip, so what you can do, you can store information really quickly onto this chip, and it's basically like a mini solid state drive if you want to think of it like that. And I think you can record basically everything about your flight, like you can record all the values for the PID loop, for instance, every loop, I think, and then you can overlay them later on with other software onto your videos if you like. Moving around, this chip up here, this is the main accelerometer, the Invensys. I think it's a 6050, but that's got the accelerometer and the gyro in there. So that's probably the most expensive chip on the board. I think they're still around. I think they're still, he's still going to be paying $10 or so to buy those individually. Below that here is the compass. So that's a magnetometer below that one. And on the Acro version of the board, that is unpopulated, so that chip is not there. And below that one there is the barometer, and over here that one's unpopulated. We'll have a closer look at that in a sec. And moving around, we've got probably a power regulator there, and there's a few transistors here. I think that's for inverting the signal for the FR Sky telemetry. And then this one here is a Scilabs chip for converting serial, which comes from the MCU, and converting it to USB so you can plug it into your computer. And that was pretty good. I just had to install a driver and it works really, really well. This sort of chip is probably going to take over since the whole FTDI gate and all the fake FTDI chips that went out a while ago. Anyway, off topic. Got our LEDs on the left here. And another difference is this one's got the Afroflight logo on there while this one doesn't. And we'll turn them over. Just check focus here. And looking on the back, you can clearly see the nice matte finish that this one has, rather than the shiny reflective coating that the cheaper version has. And you can also see the quality of the silkscreen. We'll get a closer look at that in a bit, but the quality of the silkscreen in the original one is much nicer as well. Now this unpopulated part here, this is for a connector, and it's a connector for basically for developers to hook basically a debug socket up to that, so you can plug that debug socket into your computer and your compiler, and then you can step through code as it's running on the chip itself. Not something, if you don't know, if you've got no idea what I'm talking about, then don't worry about it. Don't worry about it. There's nothing missing here except a plug used for debugging. That's all you need to know. And then there's a couple of other ports here. You'd have to look at the manual for exactly what they are. Some of these, I think like that little GPIO one is a 3.3 volt tolerant. It's not 5 volt tolerant. This one's 5 volt tolerant. They're just extra pins that have been exposed from the main MCU in case you want to have any other features, because these little chips are very, very capable. You can get them to talk to GPSs and all sorts of stuff, and with the right firmware, I know with the Tower Labs you can do return to home and all that sort of stuff with GPS. Anyway, we'll go even closer macro and get a closer look at this. Alright, so there's our main processor on the cheaper board. Interesting to say, production year, I think that's 93. I think that's how it works. And MIS, I'm guessing, is that Malaysia? I'm not sure. And then we look at the Naze32 one, 93, and CHN, perhaps that's China. Maybe this one was made in China, the other one was in Malaysia. Not sure, but certainly the chips themselves should perform just as well as the other one. There's our accelerometer on there. Very hard to see the text on it if we get the light right. There we go, InventSense MPU 6050. And on the other one, that's the same, with a nicer quality text on there, I think. Maybe these ones just didn't get moved around as much while they're in the bag or whatever. Now, and interesting to note about these accelerometers, there's a lot of technology in there. There's tiny little vanes and stuff, and there's actually physical moving parts in these accelerometers, and they're very sensitive to heat. I know I've tried repairing other boards, and if you get these too hot, they will break, they will fail. And I don't know, they've probably got maximum G ratings as well, so you don't really want to drop these on a hard table, like from a meter onto a solid surface or something. They could probably damage these as well. Worth a look at the specs, because I think they do have some limits. Now these chips, if you want to buy the chips themselves, if you want to buy them from, say, Mouser or something in the States, they're actually classified as a they've got export restrictions on them because they're used in they can be used in military hardware, because of course, you know, all weapons and stuff need guidance, don't they? So some pretty cool technology in there. There's the data flash. I'll link to the specs on that one. 16 megabits maybe, so I'm not sure on the size of that. Now apparently you can interchange quite a few different chips, and this is one that you could probably solder on yourself onto the Naze Acro if you were willing, because those are quite big pads there, and it's quite a big chip compared to everything else. Now there's our main USB chip. These are our parts. I think these are the ones that do the inverting for the FR Sky telemetry. Let's see if we can see any of those tracks under there, under that black silk screen. I'm not sure. I'd say maybe that's inverting stuff and signal inverting. That's probably power regulator or something. Now, the barometer. The barometer, you can see there's two holes. Now these holes are necessary for the barometer to work, so the airflow needs to be able to get inside there and then move the tiny little parts. There's a little, it's a little pressure chamber with a thing that pushes back and forth. I've got a video where I've shown like my old Vario, which I used to use for hang gliding, and that's like as old as me, and it's got a gigantic version of one of these. It's like the size of 2 fists. It's huge, and they've miniaturized these so much. They're in a tiny little unit like this. Now you really got to be careful with these. You can't get stuff in these holes obviously and put glue over them and that sort of thing. But one thing a lot of people have, they go to fly these and use the barometer as an altitude hold, and then the multirotor will go up and down and go out of control. What you need to do to prevent any stray air, like prop wash from the props or just the wind blowing on it affecting the air pressure reading, what I do, I put hot glue around here, around the other components, like in a fairly big circle, and then I get a piece of cotton wool and just stick it on the top. Just push it on once and then cut away a bit, so you end up with this little white fluffy bit on your board. You probably want to make use of these too before you do that. But a necessary thing if you're going to use the barometer on there, something you don't want to forget. Otherwise, it'll just give you all sorts of false readings and it won't work very well at all. Now, another thing worth noting is the quality of the silk screen on this, and that's the silk screen is the printing that goes on top of the PCB, and that's the last thing. And you can see that it's really nice quality and quite sharp there all around. And if you look on the clone board, you look on the back, for instance, these pluses and minuses are all a bit crooked and the edges are fuzzy and all that sort of thing. It looks like there's a Chinaman's fingerprint on there. On this one, they're really sharp and clear, and there's no question what they are. The numbers here are actually a bit smaller than the ones on there. And these ones, these markings here for the extra I/O ports, again the text is much smaller there. Now I'm going to try something a bit different. Let's see if we can get an end-on look in the USB plug there. It's amazing that these are rated for thousands and thousands of removes and inserts, but what usually happens is the plug itself won't fail, but these mounts on the board will usually fail first. Now this is the clone one, and there's looks like there's sufficient solder in those anchor points, and this is the original one. So this one's pretty much brand new, and it's got look decent quality. There's the anchor points. They seem to have less solder in them, but I'm sure they're strong enough. They've got to be strong enough. But you want to be careful with these. Like they're anchored to the circuit board itself, so you really want to be careful. If you break these, those pads will rip up, and you pretty much screwed your whole board. You won't be able to program it anymore. You won't be able to connect it to your computer. So you want to be careful with these connectors, as careful as you can. It's one thing, one thing about keeping these boards really small is having that small connector. Okay, so as promised, this is the Naze Mini. Now the main differences between the two, obviously, it's a lot smaller. It doesn't have the Scilab's USB chip, so to program it and everything, you need to hook up an FTDI programmer to the TX and ground pins there, TX, RX and ground pins, if you want to be programming it. And it does have, it's got a barometer. There's a tiny barometer on there. It's much smaller than this one, and it looks like that barometer's only got one hole as well. You've got the accelerometer, the Invensys accelerometer on there, of course, and that's it. There's no magnetometer. There's no room for one of these data flash cards either, but you can expand it, and there are ports so you can add your own magnetometer. And I've looked at some posts, and people prefer to add the compass, the magnetometer, out on extra wire so it's well away from the airframe so I can get a better reading. So you can do that with this little board. Anyway, I'm yet to use this. I've still got to learn a bit, but I think the main resource for it is actual on a Busemark and the manual for that little board. But it's really nice, really tiny, much thinner. It's a thinner PCB as well. It looks like half the thickness there. I don't know if you can see that. So much lighter. It's probably about a quarter of the weight of this one here. Anyway, thanks for watching. Little introduction. Hopefully you can see the difference between the two. And if you've enjoyed this video, give it a thumbs up. If not, give it a thumbs down, and I'll catch you next time. Cheers.